today we're going to do a vlog on calculations, but we must know the term concentration. And the reason why is because generally reactions occur in solutions. Now solutions are actually measured using concentration, and all that means is a measure of the mass of solid in a particular volume. So the term you need to use is number moles equals concentration times volume. Now for the concentration, the units are moles per dm cubed, or it's often written as mol dm to the minus 3.
So can I just check something? If I'm writing it in this format, I don't have that line there. I just have the minus and the little 3.
Correct, and I'll just explain that, Dr. Bourne, because if you have mole dm to the minus 3, the way you can interpret it is the number of moles divided by volume, dm cubed.
1 decimetre cubed. So the number of moles divided by the decimetres cubed. Okay, so I'm getting the idea that when we're dealing with solutions, the units of concentration, or the units we're dealing with, is very, very important. We must focus on the units.
Yes, because it gives you an idea of how much solid is in that volume.
Okay.
Now there is a way to remember this formula, and it is, Dr. Bourne.
Well, if you've got moles equals concentration times volume, concentration times volume is CV, so I'd be thinking moles, my CV, because we all are dealing with CVs the whole time, so moles equals CV, and that's an easy way to remember. My CV.
V.
Moles equals concentration.
Very easy to remember, Dr. Bourne.
Times
Well
volume.
done. Now, one of the things that most people actually get wrong is the conversion of the units. So generally volumes can be measured in cm cubed or dm cubed. Now you need to know how to convert those units.
Okay.
So how would you suggest you do that, Dr. Bourne?
Right, so if we're looking at our conversions here, centimetres cubed, those are the ones we come across most commonly in the lab. Most things you do in the lab will be measured in centimetres cubed, and they are smaller than the dm cubed. So if you want to convert from centimetres cubed to decimetres cubed, you just have this little way of remembering CD. Do you remember those? We used to have CDs. CDD, centimetres cubed to decimetres cubed, divide. So what you have to do is divide by 1,000. So you have to remember to divide and what you divide by. So centimetres cubed to decimetres cubed, CD, D is divide by 1,000.
Oh, so CD was those discs that you used to be able to play music
Yeah.
on, and that was a bit before my time.
Oh, yes.
And then you do CDD, which involves dividing by 1,000.
Yeah. So this
Perfect.
is just a little
Great.
tricky way of remembering it. It's not anything mathematical, it's just a way of helping you remember. Now if you're going from decimetres cubed to centimetres cubed, you're going from the decimetres cubed, the big one, to the small one. You just do the opposite. You don't have, if you can learn the top one, the bottom one is just the opposite. So you'd multiply by 1,000. Now can you give an example, Miss McLaren, so we can practice
I
that?
think I prepared one earlier, so
Good.
let me just check. I'm going to go for the first one,
Right.
cm cubed to dm cubed.
Great.
So if we have 250 cm cubed, Dr. Bourne,
How many dm cubed? Is
how
that what
many
you're asking?
dm cubed would that be?
Okay, so I go CD, I'm going from centimetres cubed to decimetres cubed.
That's correct.
So it's CDD, so it's divide. I've got to divide by 1,000. Now I divide by 1,000 in a very simple way. I take my decimal point and I go, that would be 1, 2, 3. So my decimal point now moves to here. So in terms of dm cubed, it's going to be 0.25 decimetres cubed.
Perfect. So that's 250 divided by 1,000, which gives you 0.25 dm cubed.
Yes.
I think you're correct.
Okay, let's do another one.
Let's move on to the next point.
Okay.
So dm cubed to cm cubed. Now we're starting with 0.75 dm cubed. So Dr. Bourne, how many cm cubed?
Well, I've got to do the opposite thing I did before. So instead of dividing, I'm multiplying. So I'm now going to move my decimal point 1, 2, 3. So I'm going to end up with a 0 there. So it's going to be 750 centimetres cubed.
Perfect. So let me just reinforce that. So if it's 0.75 dm cubed, you multiply by 1,000, which gives you 750 cm cubed. Well, I think actually, Kim, I think we've actually sorted out concentrations.
One thing about that I think that we ought to point out is that if the concentration units and the volume units have to match. That's what you've got to be very careful about. So if your concentration is in moles per decimetre cubed, your volume must be in decimetres cubed. So always look out for that.
And I think also if you know the units of concentration, then it should be more straightforward. So if the units are moles per dm cubed, can I have that pen just for one moment? So your volume's got to be in dm cubed, and your concentration, you know, here you can see you've got moles, which is related to that.
Yeah.
So it's fairly straightforward. I think that now we actually have a solution, and as you know, chems always provide solutions.
Don't
Dr. Bourne.
they just?